This is entrance exam solution set number 7, and today's chapter is aldehyde and ketone, and it is basically on introduction. Whatever the question was asked from the entrance exam on introduction will be discussed in this chapter. Here, first of all, I will start with exemplar solution, and these are the very important, and each year some questions are often asked from exemplar. So number one is was given in exemplar, EXEMPL, exemplar solution, and ethyne and HgSO4 and H2SO4. Sometimes it is given in this way in presence of water. What will be the answer? I will give you the shortcuts, and while I will going to solve the question answer, I will explain the reason how. So here the main fact is water. Water breaks up into H and OH. So you should not think about this. Means out of this water you have to add H2 and O. These two adds up. This is the technique. How it gets added? This is very simple. This is the carbon having no hydrogen, or the carbon having less hydrogen should get O, and carbon having more hydrogen should get H2. So your answer is CH3C, and O should come here, and in CH part H2 will go. So here O and here H2. This is the trick, and it is very important to get ketone, and very often asked in the entrance exam. This is a solution from exemplar solution. Number one, reactivity of ketone and aldehyde. You are given CH3, and very often it is asked arrange in increasing or decreasing order of the reactivity of this group. The main fact or funda of this question to solve lies on the reactivity of these two groups, and if you know this, you can very easily give less than or greater than. Minutely follow me, I will show you the trick. The CO and CH3 group, the reactivity this is the main part. Reactivity of CO and CHO inversely proportional to alkyl group. More the alkyl group attached with CO or CHO, less will be its reactivity. This is the main fact. So here along with CO only CH3, along with CO CH3, both are same. Here COCH, CH3COH, only R group, here 2 R group, here more R group or aryl group, there more carbon alkyl part is there. Here again more carbon in benzene, and also more alkyl group. So what we have written is reactivity is inversely proportional to alkyl part. So more the alkyl part, less is the reactivity. So your order of the reactivity will be in this way. Very simple, you know the trick. The second point is failing solution does not react with. There are a lot of options given. Does not react with what of the following? Which of the following? Answer: first of all, let me tell, failing solution get reduced or it reacts with the compound aldehyde where there is alpha hydrogen. If there is CHO group is there, and adjacent to that carbon is alpha carbon, if that carbon has alpha hydrogen, then it will react. So in your option you are given A lot of options are given. Out of this option, your answer will be acetone and benzaldehyde. Failing solution does not react with acetone or benzaldehyde, because if you draw benzaldehyde, you will get this is benzaldehyde. So benzaldehyde does not have any alpha hydrogen, so it will not react. Others compound which in the options is given having alpha hydrogen, so they will react. It will react. So the compound where there is no alpha hydrogen will not be reacted by failing solution. Next question is, so here you are asked, Kenizaro reaction will be shown by which of the following? Kenizaro reaction. Kenizaro's reaction. Kenizaro reaction will be shown by which of the following? This. Again, the question is that Kenizaro reaction will be shown when there is no alpha hydrogen. Will be shown when there is no alpha hydrogen. If there is no alpha hydrogen, then Kenizaro reaction possible. And maximum of it happens when sodium hydroxide is concentrated. Am I right? So you are asked which one of the following will not show Kenizaro reaction. Will show Kenizaro reaction. You are asked which one of this compound will show Kenizaro reaction. Answer: it has no alpha hydrogen. No alpha hydrogen. No alpha hydrogen. It is this. No carbon is there. No question of alpha hydrogen. But only it is the case where there is alpha hydrogen. Yes, there is alpha hydrogen. So if there is alpha hydrogen, it will not show Kenizaro reaction. So CH3CO CHO will not show Kenizaro reaction. Other all compound will show Kenizaro reaction. Very important points. Next question. All are from exemplar. Naturally, there is water. So you are asked, it gives A, and on isomerism it gives B. You are asked to give A and B also. So a bit earlier at the very beginning, I told you that when AgSO4 and H2SO4 they are in alkyne, so you do one thing. If it is in this way, and if these reagents are there, there is water. So what's happened? Water gets adds up like this. O goes to that carbon which have no hydrogen or less hydrogen, and H2 goes to that carbon which has more hydrogen. Am I right? So here there is no question of less or more hydrogen. All the carbon has same number of hydrogen. In this case, whatever way you add up H2 and O, it is same. Say you add HO here and H2 here, it will be okay. Your answer will be CHO3. Am I right? But here the first case I told you that if you want to do so by trick, water will be add up in this way. O will be here with no or less hydrogen, and H2 will be with more hydrogen, means CH3CO CH3. This is the answer, shortcut way. But here you are asked, there is a compound which is less stable a form. You are asked to write this name or write this structure of this compound. So how it actually adds up, that should be known to you. So you see CH3, C triple bond, CH, you are going to add this only. Actually, I have shown you H2 and O more shortcut way, but how it occurs, I am showing you. Though you see, this has less carbon, less hydrogen, so here the OH part, negative part, will go in this way with less hydrogen. Carbon having less hydrogen, carbon having more hydrogen, this H positive will go. So this will be here. Am I right? So now what's happened? This is the compound A, and that compound, this is the compound A. In the exemplar, it is asked, you are asked what is A. This is A, but this is very often goes isomerizes. It changes. How it isomerizes? That goes to here and that inclined towards it. CH3, C double bond O, CH3. What I told earlier in shortcut, you give O2 in the carbon having no or less number hydrogen. So here O, you have got O, and go give H2 here. I have given H2 here. But to solve this one, you need to know how it occurs. So I have shown you the way. Next one, in Clemmenson reduction, very important. Clemmenson reduction, what are the reagents used? A lots of reagents are given below an option. Answer: Zn, HCl, Hg, amalgam, zinc mercury, amanga, HCl. This is Clemmenson, CLE, Clemmenson's reduction or reaction. So whenever you get above the arrow zinc, mercury, HCl, you should just recall it is Clemmenson reduction. Now what is the main thing of Clemmenson reduction? It is also asked in another entrance exam that CO group, just when you give these reagents in arrow, will combust to CHO. Please keep it in your mind. Whatever the other structures are there in the huge compound, large compound or complicated structures are there, just you find out where there is CO, you place just CH2. This will be your answer. Just come to the point of the reagent. If reagent is like this, you just change CO into CH2. This is Clemmenson reaction. Next one is this one, acetaldehyde. This is a very important reaction only because of the fact that borane is there. When borane is there, there is a trick. I will show you. You minutely follow. Very often asked in entrance, and lots of entrance I am going to solve. You will get this question very often. So first of all, you come to this one, CH3, C double bond O, H. I have written it in this way. This is Grignard reagent, CH3 MgBr, CH3 MgBr. So very often I have told you that this part is plus and this part is minus. This is the style of writing Grignard reagent. Otherwise, you can't get the answer in correct way. So this is more electronegative. So electron will be written here. It is partially negative and it is partially positive. So negative part will go to here and positive part will get attached with O. So what you are getting is CH3, CH. Here CH3 is below this one and O is single bond, MgBr. And you are given there is water. Water means HOH. So automatically it will break. H is the positive part, OH is the negative part. It is negative and it is positive. So negative come to the positive and positive come to negative part. So finally your answer is CH3, CH, CH3 bond OH, and forget about this MgOH, no need to write. You have got this as A. You have got as A. And when A is there, you have got dehydrating agent, concentrated sulfuric acid. So what's happened here? CH3 C. This is the structure of A. I have written in this way. So you see, when you give sulfuric acid as concentrated sulfuric acid, it will try to lose some water from it. So OH you write here, and here you take one hydrogen from here. So the main target of this is to lose water, to release water from the structure. It is known to you. So what happens? You are getting this, and bond will be done in this way. You are getting CH2 double bond CH, and you write it in this way. It is alkene. Am I right? So your B is alkene. You have got B as alkene. So the B as alkene means it is B. Now over this B, it is given what? Borane, hydrogen peroxide, and alkali, potassium hydroxide. Am I right? So if you go through the mechanism or any other thing, the trick is nothing. Out of this you will get H and H positive. In my last class, I told you how alkyne reacts with diborane. It gives some ketone and aldehyde. I had shown you. So here, these two will add up. So if you go through Markovnikov rule, then negative part will go to this part and positive part will go to this part. According to Markovnikov, negative part of the addendum go to that carbon, sorry, here, with that carbon around double bond which has less number of hydrogen, and positive part will get attached to that carbon around double bond which has more carbon. So as per rule, H should come here and OH should come here. Since it is borane, that's why it is the trick of the question. It is exemplar, very critical and typical question here. That should not be in this way. When borane is there, hydrogen peroxide is there, it is anti-Markovnikov. You just do the reverse of this. CH2, you make OH here and CH, you plus hydrogen here. The reverse. OH should be here, but OH is at the end. You are getting CH3, CH2, CH2, OH. That is why the question is asked in the entrance. So minutely follow, when borane is in alkene, when borane is there, hydrogen peroxide and OH is there, then it follows anti-Markovnikov rule. OH will go to that carbon on around double bond which has more number of hydrogen. Next point is Jones. It is a very famous reagent, Jones reagent. It is an oxidizing reagent, and very often it is asked. Actually, it is acidified K2Cr2O7. When sulfuric acid and K2Cr2O7 is called Jones reagent, and it is a very excellent oxidizing reagent only because of the fact that in the compound which when or it is or you may write is chromic acid plus sulfuric acid. Also it is called Jones reagent. When this chromic acid and sulfuric acid is given upon any compound which has double bond in other side, then double bond is not touched. Only alcohol part will convert into aldehyde. Am I right? So double bond is not affected. Hence Jones reagent is very important. So I am taking one example here, CH2, CH, CH2, OH. Here we have given Jones reagent. Jones reagent is there. So what's happened? This is the part CH2, CH, and CH2 on oxidation will become CHO. This is the function of Jones reagent where double bond remain unaffected. Am I right? This is the vital point in exemplar all of these questions are given. I have given you the solution along with its explicit explanations. Now let me come to the solution of various entrance exam so that you can practice at home, and hence the set is 7. You are given acetaldehyde. First question, acetaldehyde HCN gives A, which on acid hydrolysis on acid gives B, and you are asked what is the compound B, the product B is. It is chain isomer, it is functional isomer, it is so answer is, out of all this option, it is optical isomers. So to know this answer, you should know how. Acetaldehyde, very simple. Acetaldehyde is this. When HCN reacts, if you write it in this way, so you can write in this way. This is plus and this is minus. This is minus part, bond withdraws here as it is more electronegative. This is what? Plus. So Cn comes to this part and O get attached to this. So what you are getting here is CH3, OH, H, and Cn is this. Am I right? So you are asked, you have got that compound is A, which on acid hydrolysis means water with acid, then this Cn become COOH. It is also known to you. Cn on acid hydrolysis becomes COOH. Now this compound B in your question is asked as chain isomer, functional isomer, metamers, or optical isomer. Answer, optical isomer, because it is center, means that carbon has attached with 4 different groups or atoms which are different, hence it is optically active. Hence the answer is optical isomers. Answer B is optical isomers. Next question in entrance, CH3, CCH3, you are asked is IUPAC name. So nomenclature, am I right? So what you are getting here is 4-methyl So first one is, in one there is hydroxy, 1 hydroxy, 4-methyl pent 3 on. Very simple. 1 hydroxy, 4-methyl methylprobute pent 3 on, or pentanone 3. Same. Next question is, an aldehyde and ketone C in carbonyl is dash hybridized. In aldehyde and ketone, say this is aldehyde and say this is ketone. So C in aldehyde and C in ketone is hybridized, say it is one hand, two hand, and double bond triple bond is assumed as one hand. So 1 2 3 means totally you are getting 3 hand. So 3 hand means this is sp2 hybridized. So both aldehyde and ketone, the carbonyl group is sp2 hybridized. Very simple. Next question, aldehyde dilute sodium hydroxide gives A is again in the option it is given that it is optical isomer, it is chain isomer, it is functional isomer, it is metamers. Your answer is given, options are given in this way. Let us take one example, aldehyde. So this is aldehyde. So main fact is that whenever there is in aldehyde dilute sodium hydroxide, you instantly mind that it is aldol condensation. I will explain it in next class in due course of time. Lots of things I will explain upon this one. So first of all, you keep it in your mind, it is aldol condensation. Aldol condensations are different types. One is simple aldol condensation and other is cross aldol condensation, another is intra aldol condensation. A lot of aldol condensations are there, but here this is aldehyde and dilute sodium hydroxide, both the aldehyde are same. This is simple aldol condensation. If it is cross aldol condensation, 4 product will form. In the last year, before that year, in entrance exam the question was appeared from cross aldol. So minority follow, this is very important. So aldehyde, this is one aldehyde, same aldehyde will come again. So I have written here CH3 CHO in this way, and other case I have written CH3 and CHO in this way. There is style of writing, you write in this way. Both are same. It is not cross. It is not cross aldol. Same ketone of same number of carbon, aldehyde of same number of carbon. One aldehyde and other aldehyde, different carbon will give you cross. Aldehyde with same number of carbon will give you simple aldol. So the writing in this way means here if it is plus, if it is minus, then this is plus. Am I right? So since it is a plus, it is electrophile. And here that actually I am not showing with the mechanism, that actually get attached with this one. The trick. One is electrophile, other is nucleophile, and that get attached to this. Am I right? So how you get the answer is CH3 COH, here H, and CH2 CHO. Am I right? So your question actually is that the product A is what type of isomers, whether it is optical isomers or what type of the compound is. This compound is actually optically active compound. Answer is optically active compound. Here carbon has 4 different things attached with this one. Am I right? This is one part, one part, one part, one part. Am I right? So on addition to this, in addition to this, if you hit this one, you will get another compound. So there hydrogen is here in this way, right? We loss out these two, not as water, we will show you the mechanism. Just you remove this one, you will get CH3 CH double bond CH CHO. In the entrance, the answers was given in this way. Which one of the following answer is not the answer of this cross-held? Question was asked in this way. So either this or that. So since it is A, your A is this, so it is optically active center because this carbon is chiral carbon, stereogenic carbon. Next question is, you are asked glyoxal is. So glyoxal, just you know the compound. This is glyoxal. Nothing to explain. This is glyoxal. You keep it in your mind. Next question is, what is the name of this compound? A bit earlier in acetaldehyde we added HCN, we got this compound, and on hydrolysis this CN becomes COOH. Now before hydrolysis you are asked what is the name of this compound. The compound is named as acetaldehyde cyanohydrin. Acetaldehyde cyanohydrin. Many of you know this compound because very often you got this. So this is all about the today's class. In the next set number 8, I will solely go on solving the different entrance exam for your practice. Thanks a lot for watching the class, and please don't forget to subscribe the class to get the new updated information.